All right. Hi, folks. And then Sabina, if you can admit folks as they come in.
Sure.
Welcome to the Multi-Sector Dynamics Community of Practice, the 2024 webinar series. And in the series today, actually, we are just going to provide a little bit of background in terms of this webinar hosted by the Community of Practice. Please be considerate when interacting with the panel, respectful, collaborative. Keep muted unless the facilitator calls on you to speak. Maintain a supportive and positive environment, and respect any questions or input from other participants. Just a little bit of background in terms of multi-sector dynamics. So we're focused on the coevolution of built natural socioeconomic systems and their responses to change, with a particular interest in human and Earth system feedbacks. As we move forward, and we'd like to invite you to participate in the community of practice. One of the things that we've been focused on is an effort to accelerate the development of needed foundational capabilities through open science and growing diverse transdisciplinary workforce. So we've been holding this webinar series and have been over the last several years trying to create a variety of community opportunities. If you'd like to learn more about some of the underlying science and motivations and goals, you can learn more in our vision report, which was published in January 2022. And you can use the QR code, or you can go to the Multi-Sector Dynamics website. We also have a new Earth's Future journal. So it's AGU Open Access Journal, special issue, focused on advancing complex adaptive human Earth systems, science, and a world of interconnected risks. We have a diverse organizer group, and we have a fairly substantial and flexible submission window through December 2024. And if you have any questions on this, I am an editor and overall organizer, so feel free to email me, Patrick Reed at Cornell University. And just to advertise before our actual webinar today, we have another webinar from our new MSD Equity Working Group that's going to be focused on metrics for human well-being with speakers Stephanie Waldoff and Brian O'Neill from PNNL, and that will be Wednesday, May 29th. And so with that, I'm going to pass to David McCullum, who will be our moderator for today's panel.
Yeah, cheers, Pat. Really appreciate it. Yeah, David McCullum, scientist at Oak Ridge National Lab, and I see, yeah, it's a good turnout for the meeting. A number of old friends and colleagues, but also a number of new names, at least to me, which is really great. The community is expanding all the time, which is exactly one of our key objectives. So the webinar today, as you know, is happening in the context of this MSD Community of Practice working group on connecting MSD research operations and planning. We call it for shorthand R2O2R, research operations back to research. And this is a working group that has been in existence for about a little more than a year now. Gokul Iyer, who you can see here, and he's Gokul's at PNNL. We stood this up, as I said, about a year ago. Richard Moss, also formerly PNNL and also at Princeton, he's on the line, and he's been facilitating and almost co-chairing with us this whole time as well. And there are two main objectives. Maybe I'll put in the chat in a little bit, or somebody else could, the webpage we have on the Multi-Sector Dynamics website, just a simple webpage for our working group. But I think it lists there these two main objectives of the working group. One is about identifying opportunities for delivering, let's say, decision-relevant insights to and then learning from experts in the applied R&D and practitioner spaces. So this kind of two-way flow is important, as opposed to just doing research and throwing it over the fence, later. And then the second key objective is elevating the visibility and ultimately amplifying the societal impact of multi-sector dynamics science, all the work that those of us on the research side are doing. And so to that end, we organize community type activities of the type we're having today, webinars, for instance. And the focus of today's webinar is obviously about, the water energy nexus. This is an important area of MSD science that a number of folks in the community, including probably many of you, are work on, and it's probably why you've tuned in today. But I would say that for the purposes of our working group and the webinars we organize, including this webinar, this domain focus, the water and energy topic, is simply provides us a backdrop really to discuss these kinds of cross-domain challenges and even opportunities that we all face, and no matter what kind of work that we do on the day-to-day in this kind of multi-sector dynamics realm. And these challenges, opportunities in terms of one, questions like how can we better engage with practitioners and decision makers whilst doing our research? The whilst part, is important, kind of while we're doing it. Again, not just waiting to the end. And number two, how can we, in the process of doing our research, better incorporate learnings from practitioners and decision makers back into our work so we can do a better job with our science and ultimately, as said, have a greater societal impact. So basically what we want to do with this and other webinars is try to think about what works well in those interactions, what hasn't always worked well, and what lessons we can kind of learn across the board. So every situation is different, right? In the water energy space, or maybe in some other MSD space, working with practitioners and decision makers, it looks different. But what are those generalizable insights that we can learn that are all useful for us across the board and for the community at large? So today we've got 3 speakers lined up, 3 great speakers coming from different places and different areas, all with some expertise around water and energy, of course. So first is Kurt Joddy from the Tennessee Valley Authority. Second, Natalie Voisin from Pacific Northwest National Laboratory. And third, Andy Jones from Lawrence Berkeley National Lab. And each of these speakers is going to have 10 minutes to make some remarks and show some slides. We'll do it in that order I just mentioned. And then that should leave us with about, we're hoping, 20 minutes or so for open Q&A discussion. Go Cool, is going to moderate. As I mentioned, Go Cool is the co-chair of this working group. And so, save your questions to the end, be thinking of them. Maybe you can put stuff in the chat in the meantime, or we'll open it up later as Go Cool prefers. But yeah, that's the general flow, and that'll take us here to the top of the next hour, 52 minutes from now. So with that, I will introduce each of the speakers maybe in turn right before they speak. And so we'll start with Kurt. And Kurt, as I mentioned, is at TVA. He's just down the street from me in Knoxville, Tennessee, as far as I know. And Kurt leads the research and development area at TVA. And nowadays, I know he's working a lot in the energy systems space, decarbonization space, doing a lot of modeling work. And that's been, I think, for some years now. But before that, he was working for a decade or more in the river management modeling, so more exclusively the modeling water side of things. So he's got this perfect blend of the water energy, say Nexus domain knowledge. I know he's going to talk about some about that today, but also about his perspectives on modeling analysis for decision making, kind of more generally, including the philosophy of modeling and so on, and lessons learned along the way. So I think, Kurt, unless I'm wrong, you don't have any slides, which is all good, and I'll pass it to you. I think, are you already on screen?
I'm ready.
All right, yeah, then I'll pass it to you. Thanks again for being with us, Kurt.
Good. Well, I'm looking forward to the opportunity. Thanks for the invite. You used the word whilst earlier when you were talking about getting researchers and operators in the same room at the same time to talk. So great opportunity here. I will admit I probably have the fewest number of publications, but I do fit that operations bill. I've focused the past 15 years of my life really helping TVA to develop good models, but most importantly, good decisions. So I will walk you through a little bit of what I've learned over that time. I do beg your forgiveness. I picked up some vertigo this weekend, so if I seem a little bit off, you can hopefully forgive that. My model that represents which direction is up has a little more uncertainty than usual. So I actually do have one slide that I'd like to share, so I'm going to go ahead and do that just to get us started. So this is the way that I have usually considered going about modeling exercises. Now leading the R&D group, but for the previous decade working in the river management decision systems. The overall product that we produce in these is decisions. So for the river system, that was 2 times a day making a schedule for 29 dams and 149 river basins. How much energy will we produce, and therefore how much water will flow, and what will the reservoir elevations be? So that's the decision. And twice a day, that schedule is going to go out come hell or high water, and sometimes very high water, right? So my practitioner's view of this whole thing is you're pulling everything forward to a decision point, to the point that sometimes a computer, but very often a human being, will be making a decision. And in order to make that decision, they can't look down into every last detail of the complexity of things. They need to understand what are the most important trade-offs that they're balancing when they make this decision. And only by visualizing that well can they make a good one. In order to visualize those trade-offs, you first got to work on exploring the possibilities, right? What's your uncertainties? What's your sensitivities? What different scenarios are you looking at for that future world? If you're looking a few days ahead, there may be a certain amount of uncertainty. You know, if you're looking 50 years ahead, there's enough uncertainty that it could drown you oftentimes. Moving on from there, you've got to have good models that are fit for purpose for exploring those possibilities, that really can tell you what those trade-offs are. And then underneath that, you've always got a base layer of computing, right? And all the models, all the hardware, all the databases in order to make that work. So, you know, that's my overall view of how this goes about. Let me stop sharing if I can. All right. So that's my overall view of how it works. And I'd like to suggest, from my perspective, if researchers can pull from operations and make sure they're answering the operators' questions and framing the results in a way that make for good decisions, we can be very effective. So I'd like to suggest maybe you could eventually rename this to O2R2O, because if you start from the operator, you can oftentimes answer the questions in a good way. A couple other things there. Occam's razor. I always like to, even now that I'm in the R&D group, go for the simplest piece of technology, because simpler is better, less fragile, and more reliable generally. And the 80-20 rule, if you can represent 80% of a phenomenon with 20% of the complexity, I usually choose to do that. Now, a few things that I've noticed working with research modelers over the years, a few pinch points. First, there's a lot of off-the-shelf software that operators have invested in oftentimes, whether it's water, energy, transportation, you name it. And so if a researcher comes out with a great new algorithm that is then very hard to adopt with folks with all these sunk costs in these models that they've calibrated and built over years, it may not reach the audience that you want. So I'd like to encourage folks to understand what model sets are out there, and to the extent you can, work with the vendors or open source folks that are shepherding the models that are already in use. Some other things I've noticed having built operational systems at TVA is that having switch hitters that can understand the scientific aspect or engineering aspect and the computer programming / modeling aspect together in one brain can really be a blessing, because particularly in operations, those are two different people, and the amount of translation that has to happen between an engineer and a programmer sometimes can slow you down significantly. So we found that hiring those switch hitters and then getting them in the same space at the same time makes a big difference. I'll speak to one of the main projects that I got the pleasure to lead was a complete revamp of TVA's operational river forecast system. And for that project, we put 5 or 6 people literally at the same conference table for 4 years, right? They didn't work on anything else, and they collaborated extremely deeply, and that's what it took to solve that problem. in the time frame that we had. One thing I found there is better to have 100% of 5 people than 10% of 50 people. Oftentimes these problems are so complex that you can only start thinking about it and understanding it after you've been talking for 4 or 5 hours, right? And so a series of a bunch of meetings with a little sliver of a bunch of people oftentimes can tend to quicksand. Getting back to the pyramid I showed, another learning we had from that project is involving the users up front and continuously made a very big difference. Testing as you go, getting feedback as you go, being very agile. We built an agile system. Software we picked was agile. The way we delivered it was agile. And now they can update that software pretty much very simply and very quickly because of that. So structuring your team, structuring the way that information flows, the skills you've got, and pulling the needs from the users can make a big difference, I have found. All right, third and last point I want to talk about is I know it's a dirty word, politics or power dynamics, right? A lot of decisions that we're talking about, especially when you get into these big water, energy, environment, nexus kind of problems, can touch politics pretty quickly. And I think that we have to be honest with ourselves as modelers that understanding just how much influence these models have and how they're used. If we don't understand the way that people use the models and the way they, sometimes immediately, but sometimes several years down the road, inform policy decisions, then we're not acting as ethically as we could. We like to think that it's a very pure way of, we're just going to come up with a model and it's going to spit out the answer. But from my experience, that's not how it actually works, right? Model is going to model a bunch of scenarios, give some trade-offs perhaps, but then it's going to go into the public sphere where there's some amount of debate, whether that's behind closed doors in a small room somewhere, or whether that's wide open to the public in a very open setting, or anything in between. Really understanding how the decisions are going to get made and who gets to make those decisions makes a big difference. And I'd like to advocate that we make our modeling efforts as democratic as possible, involving all the affected stakeholders at the earliest possible time, so that there's not some sort of institutional capture that allows people in places of power to have their views of the world brought forward in the decisions that are later made. So the governance of models is really important and can allow us to make sure that people aren't putting their thumb on the model, because it's real easy to do that. Oftentimes I've seen modelers come under pressure from a more political angle to kind of lean on a certain parameter that we know will happen or whatever, from multiple different directions, sometimes in conflicting directions. So the more transparency we can have and the more we can involve all affected people up front, will tend to clean out a lot of those kind of things. Because I think if we're honest, modelers more and more are coming to, and models are coming to rule the world, right? And a lot of decisions are made on models now. So it's up to us to act responsibly in the way that we govern these models. So that's all I've got. Looking forward to the Q&A session. Thank you for the invite.
That's fantastic. Thanks, Kurt. Really appreciate the insightful remarks. I know they resonate, with people here who are coming from different areas, and we'll have time to, dig a bit deeper into this in the open Q&A period. But yeah, appreciate your reflections. Kind of, you see this stuff on the day-to-day that many of us don't actually. So that's great. Then let's shift gears and well, I mean, it's more just kind of passing the baton to Natalie. I know she's going to pick up on some of these things as well, and then Andy later. So Natalie, I think you can go ahead if you want and start bringing your slides up. That's I see they're coming. Okay, that's great. And Natalie Voisin, as said, is at PNNL, where she is, I think, still, right, Chief Scientist for Regional Water Energy Dynamics. Correct me if I'm wrong, Natalie.
Oh.
Yep. Yep, yeah, and a lot that could be said about Natalie, but in short, a vast experience at the interface of both land and water systems, and then energy systems, power systems, electric power systems, looking at questions of resilience, energy transitions, and more. She's going to talk about some of that now. So over to you, Natalie. Thanks.
All right. Well, thanks for the introductions. Let me jump right in, providing a vision on R2O2R. I think we saw from Kurt is pyramid, and I will show just different vision that looks a bit the same, but as a roadmap. So I want to spend some time on what R2O2R could also look like. This is here a roadmap that is adapted from NOAA technology readiness level roadmaps. There are 4 phases: research, development, demonstration, and deployment. I will say that from an academic perspective, research could be deployed into 3 phases: basics, where you acquire new knowledge, then user-inspired, where this is based on general needs, and then applied, where you address specific needs. So here, this is more an operational perspective, where you have all of those phases on the operation, and the point here is to really acknowledge that there are really a lot of phases in R2O2R. There is, by design, a lot of connections where you can go back and forth, and that's just this is just very it's just very natural. And so there's a lot of opportunities in the R2O2R to practice that back and forth. It's going to be important to know where you are. Actually, going back to Kurt, I'll join you on this one. It should be at the center here. While it looks like a roadmap with an entry point and an exit point, to me, this is not linear. The entry point is actually right in the middle, starting with the O, where you have a clear need, you have an identified user, and a very specific decision. And to get there, it actually needs very close connections with the operational environment. It's actually the operational environment that is going to tell you what you need. Is it going to be a new tool, or is it going to be data sets? And also getting all of the politics that is in there that will make any of your research actionable and useful. So once you have your entry point, again, that clear need, identified user, and decision, all 3 together, then you can start having fun. That's where, from a research perspective, and here I'm going to focus just on the research, where you have top-down and bottom-up approach. Those are, this is a language that is well accepted. From the development, demonstration, and deployment, typically this is an incremental. This road is well established. So let me focus here on the right, the bottom-up and top-down. Bottom-up, it's when you start with a very specific decision. The advantage of this approach is that because you start with a very specific decisions and user, all of these roads to operations, development, demonstration, and deployment, it's already established. So it means that your innovation is going to go very fast into operations. As you start moving up, you're going to go into the research. This is where you start having some challenges, typically of scalability and generalization. But this is how the industry is working with researcher. They don't work with one researcher. They know they work through publications, and they get exactly what they need, and they bring it together to how they need it. This approach helps at the minimum with priority in research, understanding if you need to have heat waves before cold snap or so on. Nonetheless, that's one way to do the research. The other one is top-down, where you have all of this new acquired knowledge. I'm going to bring AI, ML, and a lot of buzzwords, all of those new innovation that we're all excited about. And as you go down in that readiness matrix, once you come to decisions, you're going to look for alignment. You're going to have to tinker a lot to make it work into perhaps a new decision. And that roadmap to go into the operations, those dashed line here, it needs to be established. And to Kurt's point, on the left with the bottom up, you already have the models, the commercial software that already established. Here, you may have to reinvent the entire wheel. This is going to be a very long road, my friends. because you will have to go through all of the challenges of going through institutions, compliance, relicensing, and this is needed, right? But it's going to be a very long road, so it's important to have the right expectations. The point here is that you need both of them, and as you practice R2O to R, it's very important that you either practice yourself, both of the bottom up and top down, or you partner with people and industry who is doing the one that you're not doing, because you really need both of them to move forward in science. So with this in mind, I'll provide you 3 examples of that R2O2R in practice, a top-down approach and a bottom-up approach. On purpose, I gave the exact same title. However, the outcome is not the same. So that just illustrates my previous point. And then we'll go through a level up of a top-down approach with multiple users. So the first top-down approach, this work is based on the Secure Water Act 9505 effort that is being led out of Park Ridge, and PNNL is a partner. The overall objective was to develop a hydropower assessment over the entire continental continuous US. We wanted to make it a bit advanced in the technology readiness. So we tweaked it saying, we're going to develop continuous-wide hydropower projections across decision-making relevant scales. That piece here is being informed by how decision-making is done in operations. What you see on the right, we can get on how we did it, but what I want you to see on the right here are the outcomes. Those are data sets of hydropower projections, and we identified 3 droughts in the near term and the midterm. The scale here of balancing authorities, those are energy scales where wind and solars need to be balanced, and the load as well. So each of the size is the installed hydropower capacity. The color is the intensity of the drought. The droughts were selected based on the intensity over the entire grid system. So that's where it starts being a bit more user-inspired. So all of those data sets are available. The users are input for reliability and resource adequacy. We have the same droughts at both balancing scale and UC4, which is for water management. So the goal here is to inspire and inform water managers and power system operators to understand what a drought and impact droughts could mean to them. The caveat is that it cannot be used by individual utilities. To go to individual utilities, we are working on more work with technical assistance to get the accuracy needed. So this is something to contrast with the bottom-up approach. A part of a different project, we work with the WEC, so the Western Electricity Coordinating Council. The ask was to update and enhance hydropower data sets that would feed directly into the power system model, and that was to inform their reliability studies. So very clear expectations using models that already exist, that are vetted, very clear expectations that also the information here is not just a hydropower generation at a monthly timescale. We also need information at hourly timescale that is accurate enough for this assessment. What we did on this one, so very bottom-up approach, is we still used our new knowledge at the time. This was done in 2022. The need for coincidence at the time, because we wanted to have a normal average, an average water year that was recent. You can see here on this graph the 5 most recent water year at the time, looking for something that was average across the entire WEC. That's not happening, right? So we had a lot of compromise to do, but something that we did was making sure that we were using the same year for all of the hydropower plants. We also enhanced to a weekly timescale to be more accurate, represent long-term water management, but support the hourly flexibility for the questions that people had. The point here is that those hydropower data sets, they are openly available as of today, and they are used by system operators and utilities. To my earlier point, this entire phase, like this was the data set, we use research from a bottom-up approach. The entire roadmap to deployment was already there. we also work with the production cost model, the softwares that were existing, to enhance and make sure that they could get those new data sets. So that's why it went fast. So the last example, let's level up a little bit. I might scare Kurt on this one. So this is a top-down approach where we sat down, we took a step back, and we look at the long-term energy planning for energy transitions. And based on our assessment of what is being done in operations, we noticed that the long-term planning is done in 3 steps. Scenario analysis, which is where the politics come in with assumptions on what are the technology, what the policy is going to be, and so on. The second step is then to cite what the infrastructure of the future should be. And then you check on how this infrastructure is going to be reliable and resilient to future extreme. In our assessment, we saw that all of those steps are being done in silo by different users, by different models with different climate informations and social science. So we took on the challenge with this internal projects on bringing some consistency, and we had very clear questions and anticipated outcomes. So that's what it looks in the forefront as we talk with the industry and all of the decision makers to see what they're going to get all those data sets. And this is what it looks like in the back end. Those are all of the models and data sets and outcome that needed to be developed to address all of the needs from different users in a consistent manner. So that's, from my earlier point, that's the top down, and then you have that spread between the different users. And we are really trying to merge top down and bottom up. But I want to go back to the expectations that there should only be one model for one questions, but we do need to bring those models together to bring consistency across users. So that's also one of the parts where we are. And I think that we should also embrace that complexity, and all of those data are open source data sets, models that are vetted, validated. It's modular, so you can bring in your commercial software. And that also allows to address uncertainties. So and that was a lot. Thank you, and looking forward for Q&A as well.
That's excellent. Thanks so much, Natalie. Yeah, appreciate you picking up the baton from Kurt, and then kind of highlighting some of the things he talked about as well. And let's pass it now to Andy as our third and final speaker, and then we'll move into to discussion. So Andy, as he's bringing his slides up, I think Andy, yeah, okay, great. Yeah, Andy is a staff scientist at Lawrence Berkeley Lab in Berkeley, California, and he's leading the Earth Systems and Society program there. And Andy, I know, is broadly interested in the intersection between humans and climate change and impacts in kind of both directions. And that includes work in a number of areas: food, energy, water nexus, urban systems, built environment, and others. So Andy, I'll let you take it away and highlight some of your work in hyperfacets and in the other projects. Thanks so much.
Great. Yeah. Okay. So thanks so much, David, for the opportunity to chat with you all here today. So I'm going to share a few lessons learned from the Hyperfacets project, which is a pretty large fundamental science program supported by the Department of Energy Office of Science that is focused on how do we produce more actionable and credible regional climate projections to support decision-making. And it's a collaboration with these 12 research institutions that's been going on now for about 8 years. And we've had it's been centrally organized around stakeholder engagement and co-production of knowledge. So what I'm going to share today is less so on the science that we've done and how the science has changed in response to the co-production, but some of the lessons learned from the co-production process itself. But just by way of motivation, this project is really focused on trying to address what's been called the practitioner's dilemma, which refers to a major gap between research and operations. So we've developed all these climate models and downscaled climate products from the science community, but the practitioner community finds it very difficult to understand which of these data sets and models is appropriate for different applications, how to combine them, how to understand uncertainties, how to pick out particular extreme events, et cetera. And so there's a big gap between what the science community has provided and what the stakeholder community needs. And so we've been trying to address that. And so our central motivation is this question here in the middle. Sorry, there's a lot of text, but how can we trust given climate information for actionable science, and how can we ensure its saliency? So the two ideas here are credibility of the information and saliency, meaning is it fit for purpose? To use the term that Kurt used earlier, is the information fit for purpose for different applications? So again, it's a big project. I wanted to just show some of the folks from the science team and mention that the expertise on the team is really strongly in the kind of atmospheric and hydrologic sciences, but also includes modeling of water and energy infrastructure systems, and importantly, social sciences. So Kripa Jagannathan, who is pictured here in the center, is somebody who has been co-leading the stakeholder engagement process with me for these 8 years, and her work is going to be featured prominently in the rest of this talk. I also mentioned that we have organized this project very centrally around engagement with stakeholders, and I'm showing here some of our stakeholders. These are the stakeholders that are from the water sector. There's more. There's also folks from the energy sector, and there's folks from the land sector. It's hard to put them all on a slide, but the point is that we've had these co-production processes, and the stakeholders have been involved quite intimately from the very beginning, and I'll talk more about how that works. But first, why? So this is a fundamental science project. It's not an applied science project. So why are we engaging with stakeholders? There's several reasons why. So one is that by engaging with the practice, it allows us to identify decision-relevant phenomena and key system dependencies to focus our science on. So this is kind of reflecting some of what Natalie mentioned about engaging with the operational environment to see what are the questions. We have this lens of fundamental science. Where should we focus it on? There's also, as I mentioned, this usability gap. So what are some generalizable methodologies, capabilities, and insights that we need to solve not just particular applied problems, but a whole class of problems that require new methodologies and approaches? And then we can also bring our fundamental science lens to understand the engagement process itself and study how is information used to inform decisions, and how does knowledge transform through engagement. So this is the social science of the actionable science. And then finally, our hope or our aspiration is that we're providing an evidence base to inform complex trade-offs and risks among alternative management strategies. So how are we doing this? I've mentioned this word co-production. So we do focus group discussions, interviews, workshops, lots of talking, and lots of systematic talking that's organized around a particular structure. And we record and we document and we analyze all of the engagements afterwards. We also have increasingly used shared Google Docs and things like that, where we get people to asynchronously comment and collaborate together on producing things. We've had, especially early in the project, had a strong focus on decision-relevant metrics. So what are metrics that we can use to drive our scientific investigations that reflect the kinds of things that actually matter to decision makers? And then we've also had this use of the idea of storylines as a focal point for organizing our science. So organizing the science around specific known extreme events that cause stress for our stakeholders, and then using that as a launching point to ask questions about what happened in that event, why was it significant, what do we know about that, can we model it correctly, and how are such events changing? And then we've also been doing some work more recently on trying to synthesize across the various things we've learned about user needs to develop typologies, which we hope can help us generalize from specific contexts to a larger class of problems. Okay, so storylines, again, I mentioned this, but this has been a central organizing principle for the project, that we organize our science around extreme events that cause stress. So for instance, we might ask, with Hurricane Irma, why was that a significant event? How well do our models capture such events, and how do we expect such events to be changing in the future? So now I'm going to just give you some of the, as I mentioned, we have had a social science folks on the team who've not only been conducting the co-production process, but also studying the co-production process as it unfolds. So I have a few insights to share from that scholarly work that's actually been evaluating our process as we go. So one thing is about this idea of making metrics or identifying metrics. And while we all agree that it's important to start from the operational context and say, what's important to you? In this space, especially around incorporating climate information, which hasn't previously been used, it wasn't always the best way to just say, like, so what do you need? Or what is the metric that's important to you? Because then our stakeholders would say, well, I'm not sure what I need, or tell me more about the climate information and what should I be concerned about? And so it was actually more effective to still start with the operational context, but not start with the direct question of what information do you need, but like, let's explore this context together and collaboratively understand through bringing the knowledge from different people together, understand what the needs might be and what a good approach would be. So that was one really important insight. Another important insight, now these next two slides are from one of our stakeholders, Gary Schenk, where we sort of, all started this project with a kind of an R2O2R sort of framing. It's like, okay, the stakeholders are going to tell us what they need. The scientists are going to improve what they're doing and give them actionable data. It would be nice if it was this simple. What actually has happened and unfolded in the project is quite a bit more complex. So the stakeholders have told us about their management concerns. We're a fundamental science group, so we've then helped them understand, provided theoretical knowledge that's helped them learn and understand their context more thoroughly. There's been some cooperative side projects and interactions, but really what's been kind of important distinction to make is that these fundamental science advances, really in order to be tailored to specific stakeholder needs, would ideally go through something, a more specifically applied process, something like what we sometimes call climate services, which refers to the tailoring of climate information to specific decision contexts. So we kind of have this need for climate services to be scaled up, and we also have a need for fundamental science that can provide the foundational tools and insights and methods to make climate services possible. And that there's also this opportunity for stakeholders to then act as a bridge to a broader stakeholder community. Okay, finally, another thing that's been really interesting take home from the project has been this work that we've done on typologies. So our hope is that by examining these really specific contexts, we can identify needs that map onto a broader set of problems, and that we can develop solutions that apply not just to that one specific problem, but to a bigger class of problems. So then an important question then is, what are the like natural groupings of problems that need to be solved? And one way to approach that is to ask, how do the various stakeholders want to use climate information? And so this is what we came up with, but through a careful examination of all of our co-production activities, is that it's useful to distinguish between uses of information that are used to broadly understand the problem, to motivate and communicate action, to inform, meaning to more specifically provide data into modeling and analysis work, to make plans and evaluate future options, to again motivate funding, which and then to finally to implement specific policies and actions. And that for different parts of the different components of this planning process, you might need very different kinds of information and different levels of credibility and different ways of handling or treating uncertainty. At the same time, we've then identified different kinds of information and metadata about climate information that would be used. So, I thought one thing that was quite interesting is that for many cases, it's the broad trend or pattern, it's the narrative that we have about how the climate is changing that's really important, for instance, to motivate or to understand. But then those more specific, very detailed modeling exercises, changes in certain metrics, understanding the drivers or the processes, those are also required when there's really kind of high stakes infrastructure investments on the line. And then also a third type of information is actually information about the credibility, or information about the uncertainty, or information about how the science is improving or has improved. So anyway, that's check out our paper that was published last year on these typologies if you're interested in learning more about that. And I will end with a few closing thoughts. Sorry for all the text, but climate change and these multi-sectoral considerations, they really present unique challenges for planners. And so getting to understand what actionable science is needed really does require this back and forth between practitioners, scientists, and intermediaries. It's not something that either side can come up with on their own. At the same time, each problem is not completely unique and idiosyncratic. There are commonalities that we can find that cut across the typical sectoral and regional way that we often organize things. And so these typologies can help us identify what those common challenges are. And they point to the fact that there are needs for fundamental science that can inform multiple challenges. And also, but there's still this need for boundary spanners and applied work in order to really tailor these things to specific contexts. And then finally, co-production is this time and resource intensive thing. Kurt talked about, a group of people spending 4 years on something. And so I think an important question perhaps for us to discuss is, how can we both go deep in these co-production processes and really do it right, but at the same time identify transferable knowledge that can be moved to other contexts so that we can be more efficient and effective, and learn and hopefully get things done a little bit faster. So I'll stop there. Thank you very much.
Well, thanks, Andy, and thanks, Natalie and Kurt as well, for very interesting talks. And also thanks for, I think, sticking to a little bit of time. So we have like 12 minutes for discussion. So let me open the floor for any questions. So people who are interested to ask questions of our esteemed panelists, please feel free to raise your hand. And while the audience is thinking about questions, feel free to post them on chat or just raise hands and ask them. Either way is fine. I'll probably go ahead and ask one question of the panel, and either of you can choose to respond to it. So the first question I have is, how do you work with stakeholders to characterize and communicate uncertainty? I think it sort of came out in some of your presentation, but I was wondering if you had some additional thoughts to share on that. So I guess probably Natalie or Andy would probably be the best person.
I was about to deflect. It's like, oh yeah, Kurt, what do you think about it? That'd be good to hear. The uncertainty piece, I think, is sometimes it's relevant and sometimes it's not. For example, at one of the recent workshops that we had just last week on the integration of climate in long-term planning and grid resilience, we realized that on the climate side, there is a lot of uncertainties, and the climate scientists are very comfortable with uncertainties and probabilistic forecasts and the different climate scenarios. But when it comes to the decision making, we actually realized that the largest uncertainty beyond climate is actually coming from policy, technology, like from human systems, and that our climate projections would actually have a much shorter range if we knew what the decision making of today will be. So it's kind of a little loop here where it's important as we work with stakeholders that we talk about the uncertainties that really matter, and that when we talk with stakeholders, we actually ask them for their tolerance for uncertainties. So that would be my take here on how we've been working on those uncertainties with stakeholders.
Yeah, I would say, the concept of uncertainty is really central to what we've been working on in the Hyperfacets project. Many of our stakeholders, have made it clear, like, give us the uncertainties, like, don't sugarcoat it. Like, we're engineers, we want to know what we're dealing with here. At the same time, it's useful to, I guess, partition out different kinds of uncertainty. So, there's uncertainty that arises from model credibility, and then there's uncertainty that arises from noise or variability in the Earth system. There's uncertainty, so I think that's really kind of central to this co-production thing, and there's not a simple answer. There's important things for us to innovate on the science side to better reduce uncertainties by reducing credibility issues, but also characterize and sample the uncertainties that are not irreducible. And then at the same time, what we've been finding is that our stakeholders then recognize that because many of these uncertainties are deep, that they may have to think differently about how they're planning and how they're making decisions. So it really is an iterative thing.
Cool. You have Jesus has his hand up, was first, and then Hassan has a question in the chat, and then followed by Don.
Yep. Thanks, Pat. I've taken a note of that. Jesus, do you want to ask your question?
Sure. It's actually a short question, but so in some of these efforts where you actually are integrating multiple models, right, that have different assumptions, the uncertainties behind both the inputs and the outputs of the models, but ultimately you're using them all together to make a decision that can be quite complex. How do you engage both stakeholders and even scientists, right, to sort of understand the assumptions behind this, combining all these models and making sure that there's credibility behind the behind the modeling results?
Want me to take it first? Or you go ahead. All right. It's a hard question, so thank you. And it's a great one. And I want to go back to I think when I ended my panel, I was presenting a huge framework with a lot of models. And the part that goes in there is that each of those models, we evaluated it and vetted them separately and documented them. It's important for them to be open source when we can. It's also important to use, like Kurt says, don't reinvent the wheel. If it's already there and already vetted, if you want it to be used, don't use it. We don't need a new model. It's already there. So if it can help, if this is the appropriate model to address the questions you had, then use it. And so this is where like the more, I just want to, I'll stop there. When the models are more simple, and I go back to Kurt, I think you should take it too. Simpler is good too. And so that's where also, where do you get, let me deflect with simple is good. Kurt.
I just say I remember when the word Nexus started becoming kind of the thing, I don't know, 10, 15 years ago, I guess. And the more models you put together, I think you all know this, complexity doesn't grow linearly, it kind of explodes. And even though there may be uncertainty, oftentimes the decisions to be made are very binary, right? Do I raise a dam or not? Do I build a gas plant or a solar plant, right? Things along those lines. And people are better at understanding uncertainty than you might think if you put it in terms that they can understand, right? I've heard somebody use the example of, do I need to fill up my gas tank, right? Well, what's the probability that the traffic's going to be bad, right? What's the probability that I'm going to have to take a detour, some of those things? And putting that in people's minds, they can handle uncertainty better than you might think. And they'll use some sort of back of the envelope heuristic, and it may not satisfy your nature as a modeler, but they'll have means. And I'll say, for TVA's perspective, the ability to make long-lived capital investment decisions when there's a lot of uncertainty. When somebody figures that out, you let me know. I think I've got a decent beat on it, but getting that percolated through all of TVA and through our executives and our stakeholders is another story, and it's not very easy. So I think we need to be more like our grandparents, and at a certain point, just make some capital investments. We're letting our infrastructure crumble because we feel like if we pay a nickel more than we absolutely have to, we can't build that. We've got to get the absolute cost optimal solution. And sometimes you just have to say, you know what, if I spend 5% more than I needed to, it's all right. My grandchildren will thank me for it.
Thanks, Kurt. So I'm gonna, for the next one, I'm gonna read in a question from the chat. Thanks, Hassan, for your question. So the question is, how do we connect operations with research that is global in scope?
7 states is hard enough for me. I don't know. Call the UN.
Andy or Natalie, any thoughts on that?
I'm trying to understand a bit more the questions. If there could be, if Hassan could expand a bit more what he meant, that would be great.
Absolutely. Yeah, okay. I sometimes we work on some things or some challenges that are grand or transcend beyond borders, or the challenges are so integrated that would involve multiple stakeholders. Now, of course, the evident way to go about that would be to have multi-stakeholder consultation and participatory research approaches. But what, in your opinion or in your experience, have been your observations when you were doing such research, or you have came across such research which is so big or so complex? How do you then what do you propose the approach should be to involve operations and practitioners to come into the research scoping phase, or even like conducting or like partnering during the research?
Yeah, I could say something, which is, I think that kind of cuts to what the heart of the point I was trying to make at the end of my talk is how can we transfer knowledge from some context to others, and that there are common challenges that, you know, a land use planner in the United States and a land use planner in Brazil or Southeast Asia might encounter, and so how do we transfer knowledge from some of these contexts to others, because we really, especially in the context of climate change, have an urgent need to plan effectively. I'm less sure about the transboundary issues and kind of coordination on an international scale, but I think there can be cross-lateral learning, hopefully.
And maybe I can provide an example, because when it comes to water and energy, it is pretty incredible on the role of institutions across different countries. So there are some different concepts that you can have at the global scale, some concepts about economics and cost of water. But when it comes to going to a different country and do the long-term planning, it's a whole different world. So I agree with your challenge here. And we just, so in my experience, over the last couple of years, we had an international exercise on reviewing hydropower scheduling across 3 different countries. That was midterm and long-term scheduling for in Brazil, Norway, and the US. And the point was, it was very high enlightening on how the institutions were guiding how our own modeling is done. That was guiding how we can collaborate even across country. And once you have this bright new idea on dispatching for your own country, you actually can't generalize it to the next country. So I'm just acknowledging it without giving any solutions. But yeah, that's a challenge.
Thanks, Natalie. So we are 1 minute over our allotted time. But we'll take one more question. People that need to drop off, feel free to drop off. Siddiq, do you want to ask your question?
Yeah, thanks. I have a specific question for Natalie. So one major goal of this water, energy, environment nexus is to provide end user with the capacity to estimate their water and carbon footprint associated with electricity use. But as you showed in your presentation, that most of the research at present is focused on estimating the water footprint or carbon footprint of balancing authorities in the US under different policy and climate conditions. So my question is, how can we connect these balancing authorities with the end users, let's say with specific facility located in a region, so that if that specific facility want to estimate their water footprint or carbon footprint, how can they use that balancing authority level data, for example, EIA 930 grid monitor data, to estimate their carbon footprint?
I'd like to get to your questions where at the balancing authority, the data set that we are providing, you're right, you noted, I say explicitly, at that scale, the way that we developed it was really to provide informations at the grid scale, that were relevant. The way to get there, we had to use tools that are not operational, they are research grade. And that's because we're not, and that's why we say, use it as information. It's actually presently being used to complement utilities' own planning. They're using their operational tools. They're doing the long-term planning for their own footprint. But especially with the energy transition, they need to know what's the footprint at the entire watersheds and the entire power grid. So this is what those data sets are good enough for. Moving forward, if you see my roadmap, I was still kind of in the proof of concept, but as the different utilities sees the need for it, then there will be a call to actions to sharing more data. We're getting here in that gray area because it's becoming sensitive and there's competitions and business sensitive. But we're still moving forward. This helps in getting more data so that we become more accurate. And then one day, that's the long path that I was mentioning to my friend here. It's, in 10 years, we'll be able to move a bit more forward on that challenge.
Well, thanks, Natalie. David, do you want to offer closing remarks?
Yep, just a few words, just to say this was, in my opinion, hopefully others, this was really fantastic. Yeah, and so I think I wish that we had more than 60 minutes. Maybe next time we should schedule more. I would say that this is more like a to be continued discussion. What Go Cool and Richard and I have, and others involved in our working group have discussed, is trying to plan out a series of these type discussions, webinars over the next months, focused on other issues that are relevant for multi-sector dynamics, land systems, wildfire risk, urbanization, biodiversity, you name it. Think back to Pat's MSD diagram in the beginning. But again, having this research to operations and planning focus, and I think through that a number of themes will emerge, many of which we've already heard about today, and that's important for a cross-community, cross-domain learning. So with that, yeah, I'm happy to close. Pat, anything you wanted to say?
Just thanks everyone for attending, and stay tuned. We have another equity working group webinar, and we'll have the whole series going throughout 2024. So with that, thank you to the panel, and thank you to the audience. This has been great.
Thanks.